Welcome to the video of the exercises of lesson 2. Exercise 6. So, we are given a few graphs, K1, K2, etc. And for every graph, the number of vertices for K1 is 1, K2 is 2, etc. And for all these vertices applies that they are connected to every other vertex in that graph. So for instance K4 here, then every vertex has 3 edges. It's connected to all 3 others. Okay, then the question is, for which n is Kn a regular graph? And then you have to know, a regular graph is a graph where all the vertices have the same number of edges. So where all the vertices have the same degree. Well, if we check out the given graphs, then K1, it's only one vertex with degree 0, because it doesn't have any edges. This one has degree 1, K3 has vertices with 2 edges, K4 has vertices with 3 edges, and they're all regular graphs. The degree is the same as the amount of edges one vertex has. So, for instance, the degree of K3 is 2, and the degree of K4 is 3, because every vertex has 3 edges. So, the number of edges, well, we can count them. K1 has 0, K2 has 1, K3 has 3, K4 has, let's count them, 6. Well, if I want to calculate them for K5, that's of course a big work, but can't we just calculate it? Let's see. If for instance we look at this K4, that has 4 vertices, and every vertex has 3 edges, so 4 times 3. But then we must correct, because every edge has 2 vertices, is incident with 2 vertices. So we have to divide by 2 to make the number correct. And then indeed we get 6, as we already saw. So the number of edges in the graph Kn is n times n minus 1. So n vertices, every vertex has n minus 1 edges, and then correct by dividing it by 2. And then a simple question, for which Kn is it Eulerian? Well, we know it's Eulerian if all the vertices are even. So that would be K1, K3, K5, K7, etc. So in fact for every n which is odd. Exercise 7. We have a tree and they want us to order the vertices using the depth first algorithm. So with the help of a stack. Breadth first is a queue, depth first is a stack. And we have to choose the neighbors in alphabetical order. And apparently they want us to start with D, because that's the first one given. Okay, so D is processed. Let's cross it out. And it has 2 neighbors. And we have to put them on the stack in alphabetical order. So that is C and I. And let's just circle them if I have placed them on stack but not processed them yet. Okay, so then I take one of the stack, and we must remember that on the right side it's the top. So I take off I, and I check the neighbors of I, that is H and K. So we have C, H, K, and we can cross out I. Okay, lovely. Then we take off K, and because that's on the top of the stack, and it doesn't have any neighbors, so nothing added. Then we take off H, and we add the neighbors, that would be G and J. Okay, then we'll take out J, so that would give us J here, C and G left, nothing added because J doesn't have any neighbors. So then we take G, G goes, C stays, and we have two neighbors, F and L. So let's add them. Okay, then the next one on line is L. So L is done, only one neighbor, that's E. Then we take out E, only one neighbor, that's B. So C, F, B. Okay, the next one out is B. And this has neighbors A and C. And now we see, because C was already circled, that C is already on stack. And then if we do this depth first algorithm, the lowest one, the deepest one goes. So C gets priority. Okay, then we do C. C is out. And for C, we add F. And F was already visited once, so it goes on top of the stack. Then we process F and we process A. So this is the order of the depth first algorithm. Another tree, and now they want us to do it with the breadth first algorithm, so we use a queue, and again in alphabetical order, and we have to start with D. So breadth first, that means using a queue and choose neighbors, again alphabetical. Okay, we start with D, and let's again, if we process it, we cross it, and if we find it and put it on the queue, we circle it. So in this case we have to circle C, F and I. Those are the ones placed on the queue. We take out C, cross C, and we add B. That's a neighbor which isn't visited yet. So F, I, B. We take out F, it's this one, and the neighbor of F which isn't visited yet is G. So I, B, G. We take out I, this one, and then we add the neighbors H and K. So B, G, K. H and K. Okay, we take out B, this one. B goes. And what do we add for B? That is A and E. Okay, G goes out, across the G, and we need to add only L. H, K, A, L. So, okay, we take out H, cross him, and we add J. We take out K, nothing to add. We take out A, nothing to add. Take out E, and in fact we don't have to check anymore, because you see that the complete tree has circles, so we can just empty the queue. So this is the breadth first ordering of this tree. Okay, those were the extra exercises of lesson 2.